Can someone confirm that they can see my slides now?
Okay,
yeah, perfect. Okay, thank you. So I'm Julie. I work for JNCC, which very few people have heard of, and that's absolutely fine. I'm going to talk a little bit about the multiple marine pressures faced by seabirds around the UK. It won't exactly overlap with Beth's talk, but it will touch on some of the things that Beth has already talked about. So I think that should be quite good just to bring them all together. Just very quickly, the JNCC are a statutory advisory body to both of the UK government and the devolved governments, so Welsh Government, Scottish Government, Northern Ireland Assembly, etc. And we advise on UK-wide and international nature conservation, and we have a specific sort of management and advisory function for offshore waters, so that's waters beyond 12 nautical miles from the shore around the UK. And I'm a seabird ecologist with JNCC, and I work primarily on management of protected areas for seabirds and marine industry's impacts on seabirds across the UK as well. So not only wind farms, but just because of where we are now, and that is something that is already and is going to continue to be an increasing part of our seas, then that is quite a lot of what we spend our time thinking about. So why seabirds? Why do we care? Why are they interesting? So there are about 119 species of seabirds which regularly occur in waters around the UK. There's quite a few more which occasionally pop up, and obviously with climate change related movements, there are more and more that are occasionally seen in the UK, and of course some of these might end up being seen in higher numbers. So this isn't a fixed number, but at the moment I think this is where we are. I'm using the word seabirds in quite a loose sense, and actually I just mean anything that spends time in the marine environment. So that includes seabirds that we would normally think of as seabirds, so things like gulls and terns and puffins and other auks, but also divers, ducks, seabirds, scoters, any bird that spends time in the marine environment, basically. They are long-lived, and so that means, and they're slow breeders, and so that makes them particularly vulnerable to impacts. So things that kind of live short and fast at a population level are much better able to deal with different levels of impacts, but the kind of slow breeder, long-lived species, they find it really difficult to recover. So for example, the oldest known puffin is 36 years old, and that's largely just down to the length of time that we've been looking at this kind of thing, and that there has been bird ringing in place, etc. So that doesn't mean that that's the oldest puffin alive, it's just the oldest known one that we know its age. Seabirds are among the world's most threatened group of birds as a whole, and that's probably linked to the fact that they are such long-lived slow breeders, and so any impact can have quite a big sort of population level effect for them. And the UK is really, really important for seabirds on a global scale. So we host globally important numbers of breeding seabirds in particular, and we do also host quite a lot of them over the winter, but it's for the breeding birds that we are really, really important in particular. So we've got 8 million breeding individuals across 25 species at the last census. And just a couple of examples, we've got the largest known northern gannet colony in the North Sea at Bass Rock, and we've got, I think, about 80% of the world's breeding Manx shearwaters breed around the UK, mostly on the west coast, so sort of islands off the west coast of Scotland, like Rum is probably the most well-known one, and off sort of Wales and southern England as well. So yeah, the UK is a really great place if you're interested in seabirds, and it's a really important place for them. And they're also interesting to study because they're good bioindicators as top predators. They tell you if other things are wrong. So things like pollutants can build up into the systems of top predators, and if there's lack of forage availability, you can detect this in their productivity rates, for example. So they're really useful things to study. Lots of them are declining across the UK. So there's a census going on at the moment, and this is the last year of data collection for the current census. So the census is when we try and basically count every single breeding nest around the UK as far as possible across all the species that breed here. The last census was undertaken in 2000, but because we haven't got all the data from the current census, I can't show you all of the trends for all of the species. But this is just a flavour based on some species where we have quite good data from recent years anyway, which will probably end up being part of the census. And you can see that a lot of them are declining. A lot of these species had been declining in previous decades as well, and so this is just a continued trend. But you know, it's a mixed picture. So gannets are doing quite well. They're quite big seabirds, and they can reach quite deep waters as well. So that just provides them with a little bit more resilience, for example, because they can access a wider variety of prey. They seem to do quite well from fishing discards, although obviously that's changing now. But yeah, so you know, it is a mixed picture. Roseate terns appear to be doing really well with 100% increase, but they had declined hugely in the decades before 2000, and so they're still at really low numbers and they're still quite precarious. But obviously, you know, that's an encouraging sign that they are starting to increase, but you know, that needs to keep up for quite a lot longer. So they face lots of pressures in the marine environment, and I'm definitely not going to talk about all of them, but I'm just going to touch on a few that we tend to sort of hear about or spend our time thinking about. So Beth talked about wind farms a lot, so there's probably not much I can add. I had provided a displacement example. So if you remember from Beth's talk, she talked about disturbance, which in itself is fairly short term, but it can still have that kind of energetic stress effect. And displacement is when that becomes longer term, essentially. So if you put structures in the water and the birds don't like to go near or in or around them, then you know, that area is essentially lost to them as foraging habitat. So that's what we mean when we talk about displacement. So this is a red-throated diver. They breed in Scotland, but they'll winter all around the UK, and there's big numbers of them in the Thames and the Wash area in particular over the winter. And they're a species that are really sensitive to disturbance and will completely avoid wind farms. So they're definitely displaced from things like wind farms. And they avoid them by sometimes several kilometres. So they don't just forage just kind of on the outskirts of the wind farm, but they'll not go anywhere near them at all by considerable distances. So we can try and map what that means in terms of lost habitat for these species. So if we assume that they're avoiding the wind farms by 4 kilometres, then you get the map that's showing just now. So this is the sort of Thames area in the south of England, and the hatched line are really important habitat for this species during the winter. And they had, in the past anyway, been in sort of those areas in high numbers. And if we assume that they're avoiding the wind farms by 4 kilometres, then you get, you know, these coloured blobs with the blue 4 kilometre buffer around them. You can see that some of that habitat's lost, but it's, you know, it's not a huge amount. But there's actually evidence from some wind farms that they're avoiding them by sort of 8 or 9 kilometres, and more outside the UK. But we've got evidence from the UK that they avoid them for around 8 to 9 kilometres outside the border. And so then we get something like this. So you know, you can see that quite quickly a lot of that important habitat is lost to them over the winter. And if that's key foraging habitat for them, then that could have quite big knock-on consequences for the population. And there are other types of impact from wind farms as well. So, you know, collision, and we'll talk about that a little bit more for one of the other species I'm going to go into later. Okay, so another possible pressure is hydrocarbon pollution. And we tend to hear about the kind of big acute spills, but there's also just kind of the quiet, long-term chronic pollution that's kind of potentially having impacts as well, although we don't really know the scale of that. And if that's important or not. But we can do things to help us prepare at least for those sort of kind of unplanned but potentially quite large events like oil spills, for example. So we have maps like these for every month of the year, and it's just like looking across all the different seabird species and their individual vulnerabilities to oil spill pollution and their densities at sea during each month. And we can put all this information together to just map the sort of most important areas if there were to be an oil spill. So this basically just helps us. So if there were to be a spill during the month of June, for example, we could pull up the map for June and quite quickly see what the vulnerability is around the location of the oil spill, and we can also look at, the kind of upcoming weather and where that spill might move to, and we can quite quickly see if how worried we are and if it's going into really high vulnerable areas. And so that can help us with planning. Something that occurs on land, obviously, but still has big impacts on a lot of our seabirds is predation at the nest. So lots of small mammals can do this. So rats and cats are probably some of the most obvious ones, but it can also be ferrets and any small mammal really. Especially on uninhabited islands, rats can cause some pretty big devastation. So there's evidence from some of the islands like Rum and Lundy further south, that the removal of rats on some of these islands has led to huge increases in the numbers of some breeding birds, especially those that burrow in the ground. So things like Manx shearwater, which essentially just kind of burrow into the grass, and that's where they nest. So yeah, obviously easily accessible to rats. A little bit of good news, there's been various projects around the UK. This isn't the only one, but this is quite a good recent example of recovery projects. So they've now managed to remove all of the rats from the Shiant Islands, and they've had shearwaters and petrels return to nest there for the first time in decades, I think, certainly in a long time. So, this is something at least that is a little bit easier to manage than some of the other threats. And then the big one, of course, as Beth's already showed you, vulnerability to climate change and the different ways that climate change can impact on the species. And different species are differentially vulnerable as well. So that depends on things like the foraging strategies, and how adaptable they are as well. So if they lose one type of prey, can they just switch to something else or not? Storm resilience, because one of the things that will happen with climate change is increased frequency and increased severity of storms, and indirect effects as well via their prey and sort of wider ecosystem effects. So these are all important, but some of them will be more important for some species than others. So I mentioned gannets earlier as one of the species that are actually doing okay at the moment. They can dive quite deep, and if you manage to see them doing their plunge dive, it's pretty spectacular, and that allows them to access deeper water. And that combined with their large body size means that they can eat all sorts of different types of fish, and they can access them in different depths of water as well. So basically it just means that they're quite adaptable, they have a catholic diet, and if something's not available, they can just switch to something else. So as long as there's some food in the sea, they'll probably be able to find something suitable. Surface feeders, on the other hand, find it a lot more difficult to adapt because they can't access the deeper water. So there are more kind of limited options for them, and they're dependent on things that being near the surface and at the right time of year as well, for them to access. So they're just less resilient and less adaptable. So I did mention that there would be more frequent storms and more severe storms as well. And so individuals can be resilient to storms in terms of their kind of individual survival or overwinter survival, but also their nests can be completely wiped out by storms. So there was a study based on the Isle of May during one particular storm, and they looked at the proportion of nests that were lost by different species on the Isle of May. And they found some, quite clear indications that the species that tended to nest in more exposed locations lost a higher proportion of their nests. So things like guillemots, which just, I say nest, but basically they just plonk an egg out on a tiny little bit of rock, essentially. They don't build a nest as such. But yeah, these are just on very exposed cliff faces. And kittiwakes, they do build nests, but again, they do so on quite exposed cliff faces. So both of these species lost quite a high proportion of their nest during this particular storm. And shags, on the other hand, they can be quite variable in their choice of nest location, but they build nests, and they quite often do so kind of deep into crevices, or in caves, and just generally more sheltered and less exposed locations. So overall, they lost a much lower proportion of their nests, But what they also found is that the shags that were breeding in more, so they kind of categorised the shag nests depending on whether they were more sheltered or more exposed, and those in more exposed locations still lost a higher proportion of their nests than those in more sheltered locations. And if during a breeding season there's going to be more regular storms like this, then overall they're likely to lose a much higher proportion of their nests from year to year. And that can have quite a huge impact at a population level. And again, these are birds that they breed slowly, basically. They might try and produce 1 or 2 chicks a year. They quite often have a year off in between breeding attempts anyway, just to kind of recover their body condition and make sure that they're in good shape for their next attempt. So yeah, this can have quite an impact at a population level. So yeah, one of the things that climate change can do, that this will become a bit more clear in the next slide, I think. Yeah, so climate change will have impacts on prey for different species as well. And I think what this slide is doing is just showing you how important the sort of abundances of some of their key prey are to the overall breeding success of seabirds. So I'll be using kittiwakes for the next few slides, just because it's a species that we have quite a bit of data on. So it's a good species to use to demonstrate some of these points. They're also a species which are a surface feeder. So they are quite dependent on a more limited number of prey species. And we do know that they're fairly dependent on sand eels, especially during the breeding season. And so that just gives us something to focus our kind of data collection on, and something to look at. So this slide is from Shetland. I think this was from quite a few years ago, but there's similar trends have been seen in other locations and more recently as well. So this sort of trend holds fairly well for kittiwakes in quite a lot of different locations. It also holds for some other species, although it's not always quite as obvious or strong a relationship for other species. But what we see along the bottom is the sand eel biomass sort of within that area. So sand eel biomass around Shetland. And then on the other axis is the mean number of chicks per nest. So we call that productivity. So that's how many chicks were successfully raised through to fledging, essentially. And so in the years where there were more sand eels around Shetland, the kittiwakes tended to produce more chicks on average per nest overall. And so if we link that back to the earlier slide where I showed you that kittiwakes have been declining, in that same time frame, their productivity has been declining overall as well. And so when you link this all together, basically that suggests that one of the main reasons for the declines in kittiwakes is likely to be due to lack of food when they're trying to provision their chicks. So if they haven't got enough food available, they don't produce as many chicks. And so then the population will start to decline overall if that's a consistent trend across the years. Yeah, that's just a nice kittiwake picture. Okay, here we go. And so this is a similar but slightly different plot. So along the bottom, we've got sea surface temperature. And then down the side, again, we've got the breeding success, and this is kittiwakes again. And so each dot is a different year. And so we see that overall, the years with higher sea surface temperatures, the kittiwakes did less good and produced less chicks overall. But there's 2 lines there, and the top line is the year for which there was no sand eel fishery being active in the area. And the bottom line is the years where the sand eel fishery was being active. And so basically, even within this overall trend, we can see that removing additional sand eels kind of adds to this effect, essentially. So overall, kittiwakes do less well when sea surface temperature is higher, but they do even less well when there's additional pressure on those sand eels. So basically, there's less sand eels available for the kittiwakes. So this work itself doesn't tell you the mechanism by which the sea surface temperature is affecting the kittiwake breeding success. But from other work, we do know that sand eels tend to forage quite heavily on copepods, and copepods are affected by sea surface temperature. And just to complicate matters, sea surface temperature also acts directly on sand eels, but in a slightly different way. So sea surface temperature affects copepods, it also affects sand eels, and then this kind of feeds up the food chain to kittiwakes. But there are things we can do. So if we reduce the kind of additional pressure on sand eels, there's more of them then available for the kittiwakes, and so that provides a little bit of resilience. So it's things like this that we can use to help us try and plan how we help all these different seabirds, given that climate change is happening. I don't think we can stop that now, but there are other things that we can do to just help them be a little bit more resilient to those impacts anyway. What's next? Yeah, so this is a slide that Beth already showed you. So this is just, again, while we're on the theme of kittiwakes and sand eels, I'll just give you a quick reminder that the map on the left is essentially the locations where kittiwakes and sand eels overlap today based on the existing data that we have. And then the map on the right is projected in the future to sort of years around 2050, so 30 years into the future, and looking at the extent of kittiwake and sand eel overlap then. And obviously that's reduced, but we can use some of the kind of work I showed you around the impact of fishery as an additional pressure on their key prey, essentially. And so we can sort of, there are still ways that we can try and manage this to an extent. Obviously, we can't manage climate change and we can't stop that happening, but we can use this information to help us plan how we use our seas going forward, where to focus management. So if we wanted to do something to help kittiwakes into the future, for example, we can see from these maps where we should focus that effort. There's no point in doing something in the southern North Sea around the Thames or the Wash area because they're not going to be there anyway. So yeah, this sort of thing's really useful to help us plan how we help some of these species. So I just wanted to bring it back to wind farms again. So it's kind of almost gone full circle. So yeah, this is a map which shows some of the sort of different wind farm areas that we might expect to see in the next sort of decade or two. So the different colours just mean different stages in the planning process. So some of these wind farms are already built and in the sea, others are consented but not built or sort of during the construction phase, etc. The dark blue ones around Scotland, they're sort of big planning areas, so we might not expect all of those to be completely built out as wind farms, but you know, these are kind of open to invitation, if you like, so we can expect some development in some of these areas anyway. So this just gives you a bit of a flavour for what the sea is going to look like. So basically we know there is climate change, it's already happening, it's going to have profound impacts on some of our seabirds. We can't stop that from happening, but we have to deal with that. One of the ways we'll be dealing with that is by building lots of wind farms in the sea, you know, to this extent and potentially beyond when we go kind of further into the future. They will also have impacts on seabirds, but we need to find a way to try and think about this more holistically. And given that there's not much we can do about things like the climate change impacts as such, we need to provide resilience to these species and sort of allow them to still kind of adapt and cope and sort of still find enough food and do what they need to do, etc. So having lots of this information around, you know, what they might do and how they might respond to the climate change itself, but also other actions that we can take, can help us to kind of plan for that and to manage that as best as we can. So there's been various headlines around kind of about wind farms and, you know, why do we care when actually house cats probably kill a huge 3 billion in this particular headline, as opposed to 300,000 from wind farms. So actually, do we care? And then other headlines saying things like climate activists threatening endangered species with extinction. You know, I think, yeah, none of these are particularly accurate, I don't think. But what we do need to do is think about what does this mean for seabirds? So cats don't kill long-lived, slow-breeding birds like seabirds generally. They kill the kind of much smaller, faster-living, faster-breeding sort of robins and sparrows type birds. Some of them might be rare or threatened and sort of high conservation value, but lots of them aren't. So it's not really comparable, and the numbers, you know, shouldn't just be taken at face value, I don't think. But what it does flag is that we need to think about what this means for individual species. So we need to think about what are the main threats that they're facing, you know, seabirds as a group, but also for each species within that group, and particularly those that are declining the most. Why are they declining? How are they going to, how's their trajectory going to look going forward, and how is that going to change given additional impacts from climate change? And how can we best manage that? So basically what we need are seabird conservation strategies. So we're working on this just now. There's nothing published as of yet, but we're working on this both within Scotland and within England, and trying to ensure that they're complementary and can be considered as a whole, as a sort of, you know, UK strategy almost. So that's work that's ongoing, and essentially that will help us to take a holistic approach to all of this and assess the vulnerability of each species in light of the pressures that they are facing and are likely to face in the coming decades. And think about how we can best address these in a more strategic way, rather than just these individual project by project EIAs that Beth alluded to earlier, which is probably not the best way to help anything really, and certainly not for seabirds. And I just wanted to finish with this really. So there are lots of crises, but in terms of the environment, the twin ones are climate change and biodiversity collapse. I don't want to argue about which of those waves should be bigger, but you know, they're both pretty major. They're both happening, but also, you know, they interact with each other. So climate change is a growing threat to biodiversity, and I don't think they can be completely separated out. So let's not try to do that, and let's not manage one at the expense of the other, but try and take a more holistic view and think about what really matters for each species as well as across each group of species. And just help them be resilient, because the changes are happening anyway. So yeah, and I think that was all I wanted to say. So thank you for listening. And yeah, I think I'll pass back to the host now to do the Q&A.
Thank you very much.